Hello, everyone. We're here to start Section 2 notes, the atmosphere, for your Unit 3 Earth Dynamic System. We've already talked about the atmosphere already. We know it's a mixture of gases that surround planet Earth. Okay, but we need to talk about what makes up that atmosphere. What is its structure? First thing you need to understand is the mixture is constantly changing due to living organisms and the Earth processes. What do we mean by that? What are some examples? Well, first of all, we know that we breathe in oxygen and breathe out carbon dioxide. So breathing is one thing that we do. Okay, we also create methane gas when we die and we decompose. The volcanoes can create a lot of ash and put that into the air. Also, forest fires. That's a big thing. Those affect our Earth right now. I'm going to take out 1 second and I'll show you what I'm talking about. Here is Earth. We're going to go to air and we'll look out. Nope, let's go to chem. Okay, and you can see on here what's happening. And there's actually, let's zoom in, looking at California. So this is the chemical composition, and we know that California has been having those terrible, deadly forest fires, and you can see all the chemicals that have been released in the air from that. Okay, now down here, what's this? Well, that's Mexico City. Okay, so we have a lot of people there, a lot of smog. Okay, what do we have over here? Oh, you've got New York. Okay, so a lot of different things happening. Looks like there will be some forest fires up here too. Not sure, but this is all things that happen to our atmosphere. Okay, so zoom back out. A lot of different things going on in our atmosphere at one time. Okay, so let's go back, talk a little bit more. What is our atmosphere? What are the composition? Okay, well, as you can see from your graph, I don't know if you would have guessed this, but the majority of the gases in our atmosphere is actually nitrogen. Okay, makes up 78% of our atmosphere. One of the reasons is because when we decompose as dead plants or volcanic eruptions, it gets put into the atmosphere. But it's also very hard for us to get out. We don't breathe in nitrogen. We need it, but we have to eat it in order to get it. Very few organisms can actually get nitrogen out of the atmosphere. It's called nitrogen fixation, and we're going to talk a little bit more about that when we do the chemical cycles for atmosphere after Christmas. Okay, or well, after the New Year. So number one in gas is nitrogen. You're going to need to know that. Okay. Number two, thankfully, is oxygen. Okay, makes up 21%. But what you may not have known is, where does most of our oxygen come from? You're probably going to tell me trees, but that's actually not true. Okay, a large portion of our oxygen does come, or a nice portion of our oxygen comes from plants. Okay, but it's not old trees. It's actually new plants, new growth. All those growing trees, they create the oxygen because they need it for food, and that's where our oxygen comes from. So actually, by trimming trees back, by cutting down plants, even cutting the grass and having new grass grow, that does help put oxygen into the air. Now, there's two-edged sword to that. But here's the biggest thing, and you're going to need to know this. You see this guy right here? This algae? 80% of the oxygen that is in our atmosphere comes from algae itself. Okay, so it actually comes from what we call phytoplankton. Algae is a type of phytoplankton. So 80% of the oxygen in our atmosphere comes from phytoplankton, and you're going to need to know that. That's a big thing. Okay, so we don't actually need to. We need to worry about what's happening in our oceans as well as what's happening on land. Okay, so make sure you write that down somewhere. 80% of our oxygen comes from phytoplankton. Now, the funny thing is, you're not going to like this part, atmospheric dust makes up another portion of this. So what is atmospheric dust? Well, first of all, it could be dust, soil, rocks, that sort of thing from our atmosphere. Okay, so dust, soil, okay, ash from volcanoes, from burning of other things. But it also could include, and I don't know if you guys know this, but most of the dust in your home usually includes dead skin cells floating around, or small pieces of hair, or even cloth. Okay, it could also be bacteria, pollen, okay, or other aerosols. And the word aerosol actually just refers to small liquid droplets, okay, that are light enough to float through air. So when you guys spray Febreze around, that's an aerosol. You can sort of see the droplets hanging out in the air. So that's what we talk about when we have aerosol. So that's the majority of our atmosphere. Okay, you've got the nitrogen, and you have the oxygen, and everything else makes up just that one small percent. Now, other things we need about the atmosphere, the structure, is where is most of this gas? Well, most of the gas actually occurs within the first 30 kilometers of our atmosphere, okay, or 18.6 miles. Gravity pulls all that gas towards us. Now, there's not that there's no gas up here in the higher parts of it, it's just that there's less and less, okay? So gravity pulls the air down, and as you get close to Earth, the density of the air gets thicker. So density actually decreases as altitude or your height above the Earth increases. So as you go higher, density decreases, there's less air pressure, that sort of thing is happening. Okay, that's really important for you to understand. You are going to have a test question over that, by the way, just so you know. Okay. Now, as with these different increases and decreases in things, there's actually something else that's decreasing or increasing, and that's how we get our layers of the atmosphere. So part 2 talks about the layers of the atmosphere. We have 4 basic layers, and you should have this diagram in your notes, okay? And it's based on the temperature changes. You can see this red line. That's actually part of the graph. Down here in red, you can see the temperature. So here you have 0 degrees Celsius, right? Because that's what we're used to in science class. Okay. I want you to notice what happens as you increase altitude. As your altitude increases, what happens to your temperature? Well, it starts to decrease, right? It actually goes down here, okay? And then it increases again as you go up. And you can see that it sort of makes a pattern, and that's where you get your layers from. So I want you to be aware of where those are coming from. Your first layer is the troposphere. It's the lowest layer. It's the one we love because it's where we are, and it's where we breathe, okay? It's also where most of our weather occurs. So I found this really cool picture, I like it, of a cumulonimbus cloud, okay? And you can see it spread out. It sort of hit a wall here. That's the temperature change that you see happening as those layers change, okay? It's going to be the densest layer of air. Again, it's where most of our air is going to be because it's closest to the ground. But as you go up in the stratosphere, as you get higher and higher, the temperature is actually going to decrease, okay? So it gets colder as you go higher. If you know anybody or have ever been in a hot air balloon, they'll tell you that the higher they go, the chillier it gets. It's actually can be dangerous. They can't go too high just because it gets too cold for them up in that hot air balloon, okay? Next layer is your stratosphere, okay? The stratosphere is important because it contains your ozone layer, okay? The ozone layer is it's actually just oxygen, but it's a different oxygen. Oxygen itself is found with 2 atoms, but ozone is actually 3 atoms of oxygen, okay? It's not healthy for us down here in the troposphere, but that nice layer at the top absorbs sun's UV light. So it actually helps as a big sunblock for us, okay? You're going to read an article about ozone, and you're actually going to read also going to read an art or watch a video about the ozone hole. Every spring there's a hole in the ozone layer around the poles, and you're going to listen to what's happening, what caused it, and also what's happening to fix it. So you're going to watch a video on that. It'll be posted in Neo as well, and you have your question sheet to answer on it. So take a look at that. In the stratosphere, the interesting thing about this is as you go higher in the stratosphere, the temperature does something opposite. It actually starts to increase. But it makes sense if you think about it, guys. If the ozone layer is absorbing sunlight, it's going to get hotter, right? So temperature is going to increase as you go up in the stratosphere. Third layer is your mesosphere. And if you did your geosphere already, then the mesosphere simply means the middle part of the atmosphere. Meso means middle, so middle layer. Okay. The interesting part of mesosphere is that it's the coldest layer. We're moving farther and farther away from Earth's heat, and we're also not absorbing much of the sun's energy, so it's going to get pretty cold up there. Okay. Here what happens is that temperatures start to decrease as you go higher again. So we'll take a look at your graph when you're looking at that. I chose this picture to represent the mesosphere because this is actually where meteors start to burn up. This is the layer where meteors start to really experience that friction, and so they start to burn. They're broken down as they go through. So if you're seeing a shooting star, you're seeing rocks enter the mesosphere. Okay. Last layer is the thermosphere. Now, this is interesting. The name thermosphere, thermo meaning heat, that's where it gets its name from. Okay? The nitrogen and oxygen in this layer absorb really dangerous solar radiation. I'm going to move forward for a second and I'll come back. You can see here, we talked about it with some of you guys before, but Earth's atmosphere actually is not only important because it gives us air to breathe, but it also blocks harmful rays from the sun. So you can see what we call solar wind coming at the Earth, and it actually is blocking this, and this blocking that solar wind. Now this is also showing the magnetic field. The magnetic field does this as well, so they're working in tandem. Especially the magnetic field blocks the atmosphere. Okay, now as that radiation, the gamma rays and the alpha rays coming from the sun hit the atmosphere, you can see this happening. They hit those gases and they charge them up and they create ions. Another word you might hear with the the thermosphere is ionosphere, because it charges up. This is plasma. It's like lightning, okay? And it creates something we see here from above, but we're familiar with it below as the aurora borealis, the northern lights. It's actually the atmosphere stopping those harmful rays from getting in. It's absorbing all that stuff. So we have the aurora borealis in the north, the northern lights, and the aurora australis in the southern hemisphere, the southern lights. Okay? So really pretty things. But because it's absorbing all that really high gamma radiation, X-rays coming from that sun puts it out at all, it gets really hot. It can actually get up to 2,000 degrees up there. So that's why it's called the thermosphere, because it's absorbing all that light energy. Now, if you were to make it up to the thermosphere and just sit there, it actually wouldn't feel that warm. And the reason is because the air is so thin. There's so few gas molecules up there that it actually wouldn't hit your skin, and you wouldn't feel all that heat coming from them. So even though it gets very hot, we don't feel it because there's not that much air. Or you wouldn't feel it. You're not going to be able to survive up there. And again, already talked about this. It forms electrically charged atoms called ions to create the auroras, those beautiful southern and northern lights. And here, again, because it's absorbing that heat, the temperatures are going to increase as altitude increases. So as we get colder. So again, take a look at your graph. See what's happening. You're going to use this graph and the information to create that foldable for your layers. If you have any questions, let me know. All right, we'll check you out later.